Have you ever wondered what bonding feels like? And no, I'm not talking about the type where it's a parent and a child. I'm talking about the chemistry type. What? You've never had either? Well, today I'm going to teach you about one. Chemical bonding is the lasting interaction between atoms that forms compounds or molecules. There are three types of bonding in chemistry, and those are covalent, ionic, and metallic, which all occur under different circumstances. There are some key facts that we need to make sure we know before we start. Each outer shell of an electron can hold a maximum of 8 electrons. Elements react in order to achieve a full outer energy level. By doing this, they achieve the structure of a noble gas or a group 0 element, and doing so have a stable electron configuration. Ionic bonding. Ionic bonding takes place between a metal and a nonmetal. During its reaction, it's always the metals that lose the electrons, and it's nonmetals that gain the electron in order to complete its electron shell. So the group 1 metals always form a +1 ion, while the group 7 nonmetals always form a -1 ion. When the reaction is done, we call both of the elements ions. For ionic bonding, we're going to do lithium, which has 3 electrons. So we're going to do this. And fluorine, which has 9 electrons. So it's going to be like this one, 7. So since lithium is the metal, lithium is going to lose its electron to fluorine in order to help it complete a full electron shell. So in this case, you would write the lithium ion. It's now called an ion since it's lost its electron and bonded with the fluorine. So it would look like this. Has 2 electrons now and has a plus over here since it's the one that's lost an electron, and the fluorine is going to look a bit more like this. So now it's going to be negative since it's gained an electron. So now they both have a stable outer electron shell, and they're oppositely charged, so they'll be held together by electrostatic forces, and in this case they would form a giant ionic lattice. That is the name of the structure for them. The covalent bonding. In the case of covalent bonding, it's two nonmetals bonding, but not the same way we have seen in ionic bonding. In covalent bonding, the atoms share the electrons between themselves to form a single covalent bond. However, compounds can form more than a single bond, and they are the single bond, double bond, and a triple bond. For covalent bonding, we're going to be looking at water, which is comprised of 2 hydrogen atoms and 1 oxygen atom. So in this case, oxygen has an outer electron shell with 6 electrons in it. So it would look something like this. Alright. Now, in order for the hydrogen to bond, it has to form a single bond. Just like this. Now, this is called a single bond because each atom is only sharing 1 electron. Now this helps complete the outer electron shell, making it stable, because we have 1, 2, 3, 4, 5, 6, 7, and 8 electrons in the outer shell. Alright. Now for double covalent bonds, we're going to be looking at O2. Now, for double covalent bonds, we're going to be looking at O2, which is going to be comprised of 2 oxygen atoms, meaning that they have 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Alright. Now, they are both bonded with a double covalent bond because they are sharing 2 electrons each. Now, this completes the outer electron shell for each oxygen atom, making it stable because they now each have 8. So 1, 2, 3, 4, 5, 6, 7, 8. So for triple covalent bonds, we're going to be looking at N2, which is nitrogen. So each nitrogen atom has 5 electrons in its outer shell, meaning they're going to look a little bit like this. 1, 2, and 1, 2, 3. All right. 1, 2, and 1, 2, 3. Now, in this bond, each of the atoms is sharing 3 electrons from its shell, meaning that it's going to complete the whole outer shell for each electron, forming a stable electronic configuration of 8 electrons in each shell, as can be seen here, which is 1, 2, 3, 4, 5, 6, 7, and 8 electrons in the outer shell, which makes it stable. Now these share between themselves to make a triple covalent bond. Metallic bonding is the type of bonding that arises from electrostatic attractive forces between electrons in the sea of electrons. Now, it differs from covalent and ionic bonding by having a free C to Roman for the electrons. So for metallic bonding, it's a bit different than ionic and metallic. Here, each metal is going to contribute electrons to the sea of electrons, meaning that if we have iron here, which is Fe, we're gonna have all these metals floating around here. And they're all going to be held together by electrons in the electron shell. Now, of course, electrons are smaller than this, they're on drawn scale. All these are going to be positive, since they're all losing electrons, as you can imagine. Now, having a sea of electrons is what gives metals their characteristics, them being malleable because they can have overlapping valence electrons, and their conductivity. So this is it basically.